Nuclear energy is one of humanity's most powerful inventions. It can light entire countries, power cities without carbon emissions, and produce more energy from a single kilogram of fuel than thousands of tons of coal. But when nuclear systems fail, the consequences don't stay local. They spread through air, water, soil, and time. Radiation cannot be seen. It cannot be smelled. And in some cases, it lasts longer than human memory itself. Over the past century, a handful of accidents reshaped how the world views nuclear power. Some were caused by human error, some by flawed design, some by natural disasters, and some by a chain of small mistakes that slowly turned into catastrophe. Today, we're ranking the deadliest nuclear disasters ever recorded, from localized contamination to events that permanently changed global energy policy. This is Deadly Nuclear Disasters Explained. Level 0. Goiânia, Brazil, 1987. Not every nuclear disaster happens inside a reactor. Sometimes danger hides in ordinary places. In 1987, scavengers entered an abandoned medical clinic in Goiânia, Brazil. Inside, they found a radiotherapy machine containing a highly radioactive cesium-137 source. The device was dismantled and sold for scrap. What happened next was almost surreal. The glowing blue powder fascinated people. Families handled it. Children played with it. Some even rubbed it on their skin because it looked beautiful. Within days, symptoms appeared: nausea, burns, hair loss. But no one understood why. By the time authorities identified the source, contamination had spread across neighborhoods. Entire homes were demolished. Hundreds were exposed. Several people died from acute radiation syndrome. Goiânia became one of the worst civilian radiation accidents in history. Proof that nuclear danger doesn't require a reactor. Only access and ignorance. Level 1. Windscale, United Kingdom, 1957. Early nuclear technology was experimental, rushed, and often secretive. At the Windscale facility in the UK, reactors were used to produce materials for nuclear weapons. In 1957, operators attempted a routine maintenance procedure known as an annealing process to release stored energy inside the reactor core. But the reactor overheated. Fuel caught fire, something engineers believed was nearly impossible. The blaze burned for days, releasing radioactive iodine and other isotopes into the atmosphere. Milk across large regions had to be destroyed to prevent contamination entering the food chain. Windscale forced governments to confront an uncomfortable reality. Nuclear accidents could affect agriculture, public health, and trust, even without an explosion. Level 2. Saint-Laurent, France, 1980. France built its identity around nuclear energy, but early expansion came with risks. At the Saint-Laurent plant, fuel elements overheated and partially melted inside the reactor. The damage was contained, but radioactive materials entered cooling systems. Unlike dramatic disasters, Saint-Laurent represents a quieter category, partial meltdowns that reveal vulnerabilities without immediate catastrophe. These events rarely dominate headlines, yet they shape engineering standards, emergency planning, and long-term safety culture. In nuclear history, small failures often prevent larger ones, but only when lessons are taken seriously. Level 3. Tokaimura, Japan, 1999. Some disasters begin with a shortcut. At a fuel processing facility in Tokaimura, workers manually mixed uranium solution using buckets instead of approved equipment. A faster method used repeatedly without incident. Until it wasn't. The mixture reached critical mass. A sudden nuclear chain reaction began inside the room, emitting intense radiation. Workers nearby received extremely high doses within minutes. Emergency crews struggled to stop the reaction, which continued for hours. The Tokaimura accident exposed the human side of nuclear risk: routine, fatigue, normalization of unsafe practices. It showed that advanced technology cannot compensate for procedural shortcuts. Level 4. SL-1, United States, 1961. Some nuclear accidents are violent in ways people rarely imagine. The SL-1 reactor in Idaho was a small military experimental reactor. During maintenance, a control rod was manually withdrawn too far. That single movement triggered an uncontrolled power surge. Within milliseconds, water inside the reactor flashed into steam. Pressure launched the reactor vessel upward in an explosion. It remains the only fatal reactor explosion in U.S. history, involving immediate operator deaths. SL-1 demonstrated how sensitive nuclear systems are to control mechanisms, and how tiny mechanical actions can produce massive energy release. Level 5. 3 Mile Island, United States, 1979. 3 Mile Island is often misunderstood. There was no massive explosion, no city evacuation on the scale of later disasters. But the event changed nuclear perception worldwide. A combination of equipment failure, confusing control room signals, and operator decisions led to a partial core meltdown. The reactor was eventually stabilized, and most radiation remained contained. Yet public fear surged. For the first time, millions watched a nuclear accident unfold live through news coverage. Construction of new reactors slowed dramatically in the United States. Regulations tightened. Safety culture transformed. 3 Mile Island proved that perception can be as powerful as radiation itself. Level 6. Kishtim, Soviet Union, 1957. Some nuclear disasters were hidden for decades. At a secret Soviet nuclear facility near Kishtim, waste storage systems failed. Cooling stopped. Chemical reactions generated heat until a massive explosion occurred. Unlike reactor accidents, this was a waste management catastrophe. Radioactive material spread across vast territory, contaminating villages and farmland. Entire communities were relocated quietly. Maps were altered. Information suppressed. For years, the world barely knew it happened. Kishtim revealed a different danger: long-term storage. Nuclear accidents aren't only about reactors. They're also about what remains after fuel is used. Level 7. Fukushima, Japan, 2011. Nature entered the equation. In March 2011, a massive earthquake struck off Japan's coast, followed by a tsunami. Floodwaters disabled backup generators at the Fukushima Daiichi nuclear plant. Without power, cooling systems failed. Hydrogen built up inside reactor buildings, leading to explosions that shocked the world. Multiple reactor cores melted. Unlike earlier disasters, Fukushima showed the complexity of cascading failures. Natural disaster, infrastructure vulnerability, and technical limitations colliding at once. Large evacuations followed. Long-term cleanup began. Energy policy shifted globally as countries reconsidered nuclear expansion. Fukushima was not just an accident. It was a systems failure across engineering, geography, and risk planning. Level 8. Chernobyl, Soviet Union, 1986. Chernobyl remains the defining nuclear disaster. During a late-night safety test, operators disabled critical safety systems. The reactor design itself had dangerous instability at low power levels. When the test began, power surged uncontrollably. The explosion that followed destroyed the reactor core and exposed radioactive fuel directly to the atmosphere. Fires burned for days, sending contamination across Europe. Emergency responders faced extreme radiation while trying to contain the disaster. Entire cities were abandoned. A permanent exclusion zone was created. Chernobyl changed everything: reactor design, international cooperation, emergency protocols, and public trust. It also revealed how secrecy, design flaws, and human pressure can align into catastrophe. Chernobyl is not just the worst nuclear accident. It is a warning about complexity, authority, and the limits of control. Nuclear disasters are rare compared to the scale of nuclear energy use, but rarity does not equal insignificance. Each accident rewrote safety rules. Each exposed a different weakness: human behavior, engineering assumptions, natural forces, or long-term waste. The lesson isn't that nuclear power is uniquely dangerous. The lesson is that systems capable of enormous benefit also demand enormous discipline. Because when nuclear technology works, it is invisible. And when it fails, it becomes history. The world continues to debate nuclear energy's future. New reactor designs promise greater safety. Automation reduces human error. Passive cooling systems aim to prevent the failures of the past. But every modern design carries echoes of these events. Goiânia, Windscale, Tokaimura, Fukushima, Chernobyl. Not just disasters, milestones in how humanity learned to handle its most powerful tools. And the real question isn't whether nuclear accidents will happen again. It's whether we will recognize the warning signs before they do.